Hey everyone, today we're going to talk about factoring the difference of perfect squares. Let's take a look. So quadratic expressions or equations that are in the form ax squared minus c are the difference of perfect squares. You first need to check that both the a term and the c term are perfect squares with a subtractant sign between them. Then we factor it as the product of the two binomials, which winds up being the square root of the a and c terms with alternating signs in the middle. Let's take a look at a few of them. There's a few different types that I wanted to look at, so let's take a look. We have x squared minus 25. You're doing x squared minus 25. You make your two sets of parentheses. You see that there's a coefficient of 1 on that x squared, so that x squared factors x and x. Now that negative 25, remember, it's going to be the square root if it's a perfect square. So the square root of 25 is 5 and 5. And remember, they're alternating signs in between them. So one's going to be plus and the other one's going to be minus. Remember that you can check by foiling. So x times x is x squared. X times negative 5 is negative 5x. 5 times x is positive 5x. And 5 times negative 5 is negative 25. And you notice that these two terms become a 0x, meaning they cancel out, so you're just left with x squared minus 25. Now, the other type you might see is when the c term is first, and that's okay. It doesn't have to be you in the a squared minus c. It could be c minus a squared. You could rewrite it to negative x squared plus 144 if you'd like, but that's not necessary. You can just factor it like this. So now you're factoring that 144. And again, it's the perfect square, so the square root of 144 is 12, so 12 goes in the front of each parentheses. So now we're factoring that negative 1x squared. And that's going to be positive 1x and negative 1x. You can check by foiling if you'd like, but that is the correct answer. Now you've got ones where that x squared term does not have a coefficient of 1. In this case, you want to check, oh wait, our c value isn't a perfect square, and the a value isn't 1, so I'm going to need to look for a greatest common factor. And in this case, my greatest common factor is 2. So I take out the 2 first, and then I'm left with x squared minus 36. Now I factor this x squared minus 36. That c value is a perfect square, so now I can do the difference of perfect squares. So 2, and now I'm factoring the x squared into x, and now the square root of 36 is 6, so that's going to be a positive 6 and a minus 6. And again, if you FOIL this and then multiply it by 2, you should get back to that 2x squared minus 72. So now I notice that in question 4, the x squared term, or the a value, is not 1, and the c value is not divisible by any factors the same as that 9 is. So there is no greatest common factor I can take out, but I do notice that this is a perfect square, that 9 is a perfect square, and the 25 is a perfect square. So if they're both perfect squares, you can just do the square root of each. So the square root of 9 is 3, and so the square root of 9x squared is 3x. And we put the 3x in both parentheses. Now the square root of 25 is 5. And remember, it's 1 plus, 1 minus. Again, if we FOILed this, and I'll show this one, 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. 5 times 3x is positive 15x. And 5 times negative 5 is negative 25. Notice that these will cancel out to get 0x, so you're left with 9x squared minus 25. And lastly, let's take a look at this last one. I notice that x squared is a perfect square. I notice this 9 is a perfect square, but it also doesn't have a subtraction sign. So if I tried to FOIL this, or I tried to factor it, I should get x plus 3 and x plus 3. But if I FOIL that, I get x squared plus 3x plus 3x plus 9. And then you get x squared plus 6x plus 9. And that's not what we started with. So if it doesn't have a subtraction sign in between them, meaning either the 9 is not negative or the x squared isn't negative, then it's not going to be factorable because you're not going to be able to get that middle term to cancel out if you don't have that subtraction sign that the others have. So this is going to be not factorable. Anyways, let me know if you have any questions and have a wonderful rest of your day. Bye-bye.